Introduction to Sequences and Series, and Arithmetic Sequences and Series in Algebra 2. So this video is going to cover two topics in one, and it's the first 2 pages of your packet. So this first topic that we are going to talk about, it's a whole introduction to our new unit of sequences and series. So this is a big overview. A couple of things you want to remember when talking about sequences in general. All a sequence is an ordered list of numbers, and we call them terms. So an example would be 1, 4, 7, 10, 13. It's a list of numbers, and each one of these numbers is considered a term. It can be infinite, which means it never ends, or it can be finite when there is a starting point and a stopping point. So the hardest part is reading the directions in this unit. The first part, given the formula for the nth term of the sequence, write the first 4 terms. Begin when n equals 1. So before I do this, I want to talk about what nth means. N is just a number. So if I go back up here to my example, I have 1, 2, 3, 4, 5. I have 5 terms. So the first term is 1. So I can say when n equals 1, that number is 1. My second term is 4. So when n equals 2, because that's the second number in my list, that number is 4. So if I ask you for the number when n equals 5, take a moment and see what you would say. In this case, it would be 13, because that is the 5th number in my example. So back to this part here. Given the formula for the nth term, and that formula is given right here, find the first 4 terms. Okay, so in order to find the first term of this sequence, I'm going to plug 1 in for n. So I'm going to say a sub 1 equals 4 times 1 minus 3. And then we do our math. So 4 times 1 is 4. 4 minus 3 is 1. So my first term in my list is 1. Now we need to find the second term. So a sub 2, because I'm looking for my second term, equals 4 times 2 minus 3. 4 times 2 is 8. 8 minus 3 is 5. So my second term in this sequence is 5. A sub 3 for the third term, so we go 4 times 3 minus 3 equals, so 4 times 3 is 12. 12 minus 3 is 9. And then finally the fourth term, 4 times 4 minus 3, that equals 13. So I have my first 4 terms in this sequence. 1, 5, 9, 13. Now let's try another example. So number 2. I have a different formula, but I'm still finding the first 4 terms. So to find the first term, I'm going to plug 1 in for n. So a sub 1 equals parentheses negative 1 to the 5th power. You can put this in your calculator. You get negative 1. A sub 2, so I'm going to plug in negative 2 to the 5th power. Again, use your calculator. Negative 32. A sub 3, we'll put negative 3 in. Plug this in your calculator, you get negative 243. And then the fourth term, we plug 4 in for n. Negative 4 to the 5th equals negative 1024. So my first four terms in this sequence are -1, -32, -243, -1024. And then if we look at 3 and 4, again, a sequence, they usually have patterns. So for number 3, if I was to write the next term, I go 1/3, 2/3, 3/3, 4/3, 5/3. The next term would be 6/3. Now number 4, I go from -1 to +1. So that means I'm adding something. Well, I would have to add 2 to get to that. So now I'm at 1. If I add 2, I get 3 plus 2 plus 2. So my next term is 9. So this first part covers a big overview of what a sequence is. Now let's talk about the second half, a series. A series is the sum of a sequence. So we're still going to have a list of numbers, but we're going to add all those numbers up. The way we tell you it's a sum, the way we tell you it's a series, we use this crazy E. So if I look at number 1, write the terms and then evaluate. So with number 1, the way we read these E's, let me come over here, and you will want to write this down. Whatever is at the bottom of the E, that's our starting point. So that's the first number we're going to plug in for N. Whatever's at the top of the E, that's our ending point. So that's the last number we're going to plug in for N. And what's next to E, that's the formula we are plugging into. So if I look at number 1, I'm starting with 1. That's on the bottom. So if I take that 1 and plug it in, I get 2 times 1, which equals 2. And I have to go all the way up to 4. So then the next one I need to plug in is 2. So 2 times 2 is 4. And then 2 times 3, which is 6. And then 2 times 4, which is 8. So those are the terms in my sequence, 2, 4, 6, 8. But because this is a series, I need to then add them all up. And you can use your calculator, but we can go 2 plus 4, which is 6. 6 plus 6 is 12. 12 plus 8 is 20. So my final answer is 20, because that is the sum of all the numbers in that sequence. Now let's go to number 2. And remember, if this video is going too fast, make sure you pause. Okay, so the number I'm starting with is a 1, so I'm going to plug that in for my formula. And I'll get -1 plus 2, and that equals 1. And I have to go all the way up to 7. So then we go -2 plus 2, which is 0, -3 plus 2, which is -1, -4 plus 2, -2, -5 plus 2 is -3, -6 plus 2 is -4, -7 plus 2 is -5. And again, the sum, when we add all these up, that's what we are looking for. So you can take a minute and pause this video and put it in your calculator, or we can do it in our head. We can go 1 plus 0 is 1, 1 plus -1 is 0, plus -2 is -2, plus -3 is -5, and then you get -9, and you should get -14. Again, just use your calculator. Now for number 3, we do the same thing. We could do the same thing. You start with 1, so you'd go 2 times 1 plus 1, you get a number. 2 times 2 plus 1, get a number all the way to 2 times 5 plus 1, and you get a number. But you can actually do all of these crazy E's in your calculator. So if we go to our calculator, we're actually going to do number 3 in the calculator. So turn it on. Now to get the E, you hit alpha, window, option 2. Now you can just type it in as you see it. So the bottom is x equals 1. So we have x equals 1. Then we can arrow up. We're going to 5. And my formula is 2x plus 1. Hit enter. And so for number 3, our answer is 35. And yes, you can just use your calculator with the e's from here on out. So that is a big overview of series. Now, if you flip the page, we're going to get a little more specific. Here we're going to talk about arithmetic sequences and series. This is just one of the types. So this is a sequence, and again, there are a list of numbers, but the big thing to remember is that there's a common difference of addition or subtraction, meaning we can add or subtract the same number each time. So if we look at number 1, it says decide whether the sequence is arithmetic. If so, give the common difference. And that we use the letter D. So to go from 4 to 7, I added 3. Did I add 3 to get the 10? Yes. 10 plus 3 gives me 13. 13 plus 3 gives me 16. So I can say yes, this is arithmetic because I added the same number each time. And that difference is positive 3. Now I can look at number 2. Again, we're checking to see if we can add or subtract the same number. So to get from 3 to 6, we would add 3. Can we add 3 to 6 and get to 12? No, so this is not arithmetic. Now here's a formula, and this is how we write our formulas that go on the side of that crazy E and the formulas we were plugging into in the very beginning. This is given to you. It is on your formula sheet for the SOL. The things you always need A sub 1 and you always need D. So looking at this next section, write the formula for the nth term, which means I need to use the thing I highlighted in green. Then find A sub 21. So the first thing I need to do is use my formula to write the nth term. So I'm going to say A sub n equals A sub 1, which is negative 3, plus parentheses n minus 1 times D, which is 4. Now you can't leave it here because it's not simplified. So now we need to distribute that 4. So then we get A sub n to equal negative 3 plus 4n minus 4. Then we combine our like terms. So we have A sub n equals 4n minus 7. So there's my formula for the nth term. Now I need to find A sub 21. So I'm going to take that 21 and plug it in for n. So A sub 21 equals 4 times 21 minus 7. Again, we can put that in our calculator, and we should get A sub 21 to equal 77. All right, now, problem 4 is a little bit different. Remember, I said you always need A sub 1 and D. So in this case, A sub 1 equals 2, because that is my first term. Then we need to figure out what D equals. So what am I adding every single time? Or what am I subtracting every single time? So to go from 2 to 0, I would have to subtract 2. And then subtract 2, subtract 2. So D is actually equal to negative 2. Now I can plug it into my formula. So A sub n equals 2 plus parentheses n minus 1 times negative 2. Again, distribute the negative 2. So we get 2 minus 2n plus 2. So a sub n equals negative 2n plus 4. And then our last step is to find a sub 21. So a sub 21 equals negative 2 times 21 plus 4. Again, put it in your calculator. A sub 21 equals negative 38. So there are your notes on arithmetic sequences. Now let's talk about arithmetic series. And again, a series is when we add all of the numbers up in the sequence. So this is how you will see it on your formula sheet for the SOL. But remember, anytime we talk about series, it's crazy E. And to write crazy E, we put the starting point on the bottom, the ending number on the top, and the formula next to it. So my directions are: find the formula for the nth term of the arithmetic series, then answer part B. So here's my sequence. I first need to write my formula. And the formula is what we highlighted in green at the top. So you can reference that. Remember, the two things I need are a sub 1 and I need d. So a sub 1 is the very first term. In this case is 1. D is what I'm adding or subtracting. In this case is 2. So once I have those two things, I can write my formula. A sub n equals 1 plus n minus 1 times 2. After I distribute, I get 1 plus 2n minus 2. So then when I combine my like terms, I get a sub n to equal 2n minus 1. So there's my formula. Now it tells me in part B, write the formula to find the sum of the first 11 terms. So that part is where I'm using crazy E. Crazy E. So at the bottom, what am I starting with? If it's the first 11, I need to start with x equaling 1. And I'm ending with the 11th term. The formula goes next to it, which we just found in part A. So 2n minus 1. Now we can put it in our calculator. When I type it in the calculator, I'm not going to use the letter n, I'm just going to use the letter x the whole time. So remember, alpha, window, 2. So we have x equaling 1 at the bottom. The top is 11. My formula is 2x minus 1. Hit enter. So my answer is 121. You will get credit on your test and quizzes for both, so don't skip writing the summation notation, the crazy E. You will have to write both of them.